Right, hello U9 and welcome to lesson number 2 of week 11. We're continuing on with photosynthesis and today we're going to be looking at what plants do with all that glucose that they make. So before we get going, just a little thinking activity for you. So in photosynthesis we use light energy and we convert that into chemical energy, which is the glucose. Glucose is chemical energy, and to do that we use carbon dioxide and water, so hopefully we are familiar with that. One of the most important products from that is glucose. What is it that you think the plants use the glucose for? Okay, so have a think about it. What do plants use glucose for? You don't need to write it down. If you want to, then that's fine. And then as we go through the lesson, you can see whether you already knew any of those. So pause the video, either think or jot down some ideas on what plants use glucose for. Okay, so we today need to understand how the products of photosynthesis, i.e. the glucose, are used. So for 2 to 4 we need to be able to list some of the ways in which plants use glucose, and we also need to have an understanding of how we can test a leaf for starch. Okay, now this is another one of the required practicals, testing a leaf for starch. You should have done it already in key stage 3, but we do need to understand this practical, what it is that we use, why is it that we do it, and also some of the safety implications in the practical. For 5 to 6 we need to describe all of the ways in which plants use glucose, including how they make proteins. That's normally the one that people forget about. And we need to be able to evaluate risks involved in the starch testing. And for 7 to 8, explain how carnivorous plants are adapted to their environments, and explain how and why plants convert glucose to starch for storage. So that is what we're going to be covering in this. Okay, so plants make glucose by photosynthesis, and it's also done by algae, which technically doesn't come under the plant group, but both of them photosynthesize and they use the pigments in their leaves to do that. But how do they use the glucose they make, which was the question asked at the beginning of the lesson? There are lots of different things that they use glucose to make. Remember, plants don't eat things, so they need to convert that glucose into all of the things that we would get from eating. Okay, so this might be new information to a lot of you. This is covered in key stage 3, so you might have forgotten it, but we're going to be talking about one of the uses of glucose, which is to provide energy, and they do that through the reaction of respiration. So all living things respire. This is how they get energy to do things inside the cell. As I say, it does come up in key stage 3, but it's actually going to be the next chapter that we cover for bioenergetics. So what I would like you to have a go at is rearranging the words and put them into the equation. We should have 2 reactants. Those are things that go into a reaction. And we should have 3 products, 3 things that come out. So can you have a go at making the equation for respiration using the words at the bottom, putting them into that equation? So pause the video and have a go at that now, please. Okay, so hopefully we've had a go at it, and we should have, as the reactants, the things going into the reaction, should have glucose and oxygen, and the products, the things that come out of the reaction, is going to be carbon dioxide, water and energy. And well done for those people who realise that it's just the opposite, the reverse of photosynthesis. So plants do photosynthesis, and then they use it to get energy from respiration. Okay, so what we're going to do now, or what you are going to do, is you're going to create a mind map in your books on how plants use glucose. So I've got here all of the ones that you need to know that they use glucose for. One of them has been done for you, which is the respiration, because I say that's going to be the next chapter. So I'm giving you that one. The other ones, though, you are going to go away and from this, and you're going to use either the book on Caboodle or other books or the internet to find out how plants use glucose to make these other things. So they use it for one of them, for example, for respiration, which is already on there, so you can add that on. So glucose is broken down using oxygen to give energy to the cell, and then it uses that energy to build bigger molecules from smaller ones. And the ones that are on the mind map are all bigger molecules that are made from glucose. So you can find out what goes into it and what it does with it and what it makes from it and why it needs that. So if you leave this video now and add to your mind map. Okay, so hopefully we have added onto there some of the things that plants use the glucose for. All of them will have glucose going in, but there might be other things going in as well, and what it is that it makes. And we will go over just to make sure you've got the important information in a second. So here are some of the important parts that we need to make sure. So if you are missing any of this as I go through it, add it to your mind map. So we've already said about respiration. So the first one, some of the glucose is used for respiration, to release energy, to build things. Number two, they convert it into starch for storage. And some of you might have found that starch is insoluble. So it doesn't dissolve in water. So it's a really good form to store away that glucose for rainy days. Number three, they produce oils or fats for energy storage. So that's the lipids. Number four, they make cellulose. So they join it together and they make cellulose, which is for the cell walls. It's very, very strong. And number five, they make amino acids by adding nitrogen, things like that to it. They make the amino acids, which you can then build up to make proteins. So if you need to add anything to your mind map, then pause the video and add it on. If you've got all of that information, then you don't need to pause. So if you need to pause, pause now. Okay, so glucose and starch. Now the reason why I keep coming back to starch is because it's going to be part of the practical that you're going to be looking at in a minute. So during photosynthesis, glucose is produced. We know that. We've done about that. Glucose is a simple sugar, so it's kind of a single unit. Now, plants can't store glucose because glucose is soluble, so they can use it to move it around the plant, but they don't use it to store it. So they convert it into starch instead, and they do that by just joining lots of glucose molecules together. Now, because starch is insoluble, it means that it won't dissolve and move around the plant, and it can be stored easily. It also means you can get more glucose into a space because it's kind of packed together. So if you wanted to add any of that information to your mind map on starch, then please do. If you already have that information, then we'll move on to the next bit. Okay, so something else that comes up in Key Stage 3 is a practical, and you would do a practical that is testing for starch in leaves. But does anyone know what we use to test for starch? Is chemical. It's in a solution. It's kind of orangey in colour. Can anyone remember what that chemical is? The chemical we use is iodine, and it's an iodine solution. And we use iodine to test for starch. Now, iodine, as the word is coloured, it's kind of an orangey solution. And if it is in the presence of starch, it will go a dark blue or black colour. We can relate the presence of starch to the amount of photosynthesis taking place. How do we do that? How do you think we can use starch or the presence of starch to show that photosynthesis is taking place? What do you think? If there is photosynthesis happening, then it's making glucose. That glucose will be converted into starch. So if there is starch there, we know that plants are photosynthesizing. And the more starch there is, the more photosynthesis is taking place. So that is why we do the starch test using iodine, because it shows us that photosynthesis is occurring. Okay, so I'm going to redirect you to a video that has got how we test a leaf for starch. So in the video, they're going to be looking at one normal leaf and one that they've covered up so that it is in the dark. We need to find out how much starch is present in the leaf. So we need to see whether it contains starch or not. So what I would like you to do when I say is leave this video, go on to the link, and I've included the link on Show My Homework, so you can just click on that. And I would like you to watch the video and then come back, because I've got some questions that are very important from the video that I'd like you to have a go at answering. So if you could leave the video now, go onto the YouTube link and watch the video on how we can test a leaf for starch. Okay, so hopefully we have watched the video on how to test a leaf for starch. As I say, you might have done this at Key Stage 3, but it does come up in Key Stage 4 as well, and it's an important practical that you need to. So from the video, and if at any point you need to go back to the video to find the answers for this, then that's absolutely fine. But these are kind of 4 very important parts of the practical that you need to know about. So question 1 is, how did the amount of starch differ in the 2 leaves? Question 2, explain your results for the leaf in the light and the leaf in the dark. So why did that happen? Question number 3, why do we need to boil the leaf first? And then why do we need to add ethanol to it, which in the video it's referred to as ethyl alcohol, which is ethanol. And number 4, why store the glucose as starch? And that's something that we spoke about earlier. So can you have a go at those 4 questions, please? Either write the questions and then your answers, or write in full sentences, it doesn't matter. But can you answer those 4 questions now, please? So pause the video. Okay, so we're going to have a look at how we did on those questions, just to make sure that we do have an understanding of the testing leaves for starch practical. So question number 1, what is it that we found? The leaf in the dark would have less starch or no starch compared to the one in the light. The leaf for question number 2, the leaf in the light has a good store of starch because photosynthesis has taken place. So you could say that it had access, or light was able to hit it, so it was able to photosynthesize. Whereas the leaf in the dark cannot photosynthesize because there is no light, which means that it doesn't have starch. It's using the starch storage up. Question number 3, the reason why we boil it is to damage the cell walls and destroy the enzymes that can have an effect on the practical. And why is it that we add ethanol? That gets rid of the chlorophyll. So it means that it's a lot clearer to see a colour change. And finally, number 4, why is it that they convert it into starch? It's because it is insoluble, so it can be stored away, whereas glucose is soluble. So if you need to make any corrections, please do now. Very well done if you got most or all of those answers correct. Yeah, those are the important parts from the practical. Okay, now something that very much interests me. I can never grow them at home, but are pretty cool plants are carnivorous plants. Now, carnivorous plants are brilliantly adapted to live in places where other plants cannot. And one of the places that they live are in bogs. Now, bogs are very wet, peaty soil, so it's very, very low in minerals, things like nitrates, magnesium, phosphates, all the things that plants need in order to grow healthily. But you can't find them in bogs, so it's very hard for plants to grow there. Some carnivorous plants, though, and some examples, common examples are the pitcher plants, Venus flytraps you've probably heard of, and sundews, which you can see on the video. There's 2 carnivorous plants. You've got the Venus flytrap, and that is a sundew plant, are specially adapted to live in the nitrate poor soil. And they do that because they catch and digest insects. And they use the minerals from the insects to kind of supplement the lack of nitrates. Now they do that by producing enzymes. So very slowly the insects will have enzymes introduced to them, and they will start breaking down, releasing those nitrates and other minerals from them. So pretty crafty little plants. Tomato plants, interesting fact. Tomato plants, if you ever touch the stem of it, it's kind of got that sticky, those sticky hairs on it. It's believed that they also are carnivorous. So insects get stuck on them, then they drop to the soil and will decompose and add minerals and nitrates to the soil. Now, what I would like you to do now is have a go at explaining why these carnivorous plants are often found growing in bogs globally, an environment where not many other plants can survive. Now, I've just gone through and said that they grow in bogs, but why do you think it's an advantage that they are able to actually grow in bogs? So have a think about it, come up with an answer. I would say that this would probably be a 4 or 5 mark question. So if we can try and get 4 or 5 points in there, that would be fantastic. So pause the video now and have a go at that question. Okay, so I've got some of the answers here. See if we got any of those. So first of all, introducing the fact that bogs contain very few minerals, such as nitrates. If you've spoken about that, that would be worth a mark. Plants need nitrates in the soil to make proteins by making their amino acids. If you've said that, brilliant, that is a mark. Many plants can't grow well in bogs. So if you said that other plants can't grow in that, that's brilliant. If you said that carnivorous plants can trap insects or use insects as a supply of nitrates and minerals, then that would be a mark. So that means that these carnivorous plants can thrive in bogs. That would be a mark. Or grow in bogs. That would be a mark. And there would be less competition. So they're not competing with other plants that they normally would be competing with because they can't grow there. So that also would be a mark. So as I say, it's probably a 4 or 5 marker in an exam. So if you're able to get 4 or 5 marks, brilliant. If you want to add anything to your answer, then please do in a different colour pen. Okay, and that is it from me today. So very well done. Hopefully we're able to list some of the ways in which plants use glucose, and hopefully we can think of some of the safety implications of testing for starch. So one of the chemicals used is ethanol, and ethanol is very flammable, so that would be a safety concern. Also, boiling water is a safety concern because you can burn yourself. Iodine as well, if you ingest it, it can make you quite ill, so that also would be a safety hazard. 5 to 6, hopefully we can describe all the ways in which plants use glucose. So good ones to remember are making proteins, respiration, making lipids, cellulose is an important one, and obviously starch. And hopefully you could have a go at evaluating risks in the starch test. So how can you make sure that you're being safe with ethanol and boiling water and things like that? For 7 to 8, explain how carnivorous plants are adapted to their environment. So hopefully you're able to answer the last question. And explain how and why plants convert glucose to starch for storage. So the fact that glucose is soluble, but starch is insoluble, so it is a better storage molecule. Okay, well done for taking part in this lesson. Hopefully you're all staying healthy and well, and you will hear from me tomorrow, where we're going to be looking at how we can use photosynthesis for our own benefits, and that will be the last lesson of photosynthesis before we move on to respiration. So have a lovely day, and you'll hear from me tomorrow. Take care and goodbye.